Have you ever seen water dance on a super hot surface, rolling around like tiny mercury balls instead of just sizzling away? It seems counterintuitive, right? As if the water is somehow avoiding the heat. Absolutely, we can find the fascinating Leidenfrost effect right in our own homes. This phenomenon occurs when a liquid, like water, comes into contact with a surface significantly hotter than its boiling point. Instead of instantly evaporating, it forms a protective layer of vapor, making it appear to float and dance. The magic behind this is the extreme temperature difference. When a water droplet hits a very hot pan, the bottom part of the droplet vaporizes instantly, creating a thin cushion of steam. This vapor layer acts as a fantastic insulator, preventing the rest of the water from boiling away immediately. It significantly slows down heat transfer from the pan to the liquid, allowing the droplet to move freely and last much longer than it would on a less hot surface. This effect only happens above a specific temperature, known as the Leidenfrost point, which for water is typically around 370 degrees Fahrenheit or 190 degrees Celsius. You can easily observe this at home, but always with caution. Heat a cast iron skillet or a nonstick pan on your stove until it is very hot. A good test is to flick a small drop of water onto it. If it evaporates quickly with a hiss, the pan is not hot enough. But if the water forms spherical droplets that glide across the surface for several seconds, you are witnessing the Leidenfrost effect. You might also notice it when an iron is too hot and a tiny bit of water hits it, or if water splashes onto a very hot stove burner. Understanding the Leidenfrost effect gives us a neat insight into how heat transfer works at extreme temperatures. It is not just a quirky kitchen trick. This principle is also used in some industrial applications to prevent overheating, for example, in certain cooling systems. It demonstrates a beautiful balance between evaporation and insulation, creating a temporary shield for the liquid. So, the next time you are cooking and see water droplets skittering across a super hot pan, you are not just seeing evaporation. You are witnessing a cool physics phenomenon, a mini shield of steam protecting the water and showcasing the unexpected behaviors of liquids and heat right in your everyday kitchen.